All right, gang, the second problem, I had technical issue. Well, I actually didn't have technical issues. I had an interruption. I had a delivery, and then my reaction to the uh, interruption led to a technical issue, which was kind of goofy. But anyway, so here we are. So is there a difference in satisfaction rating of traditional cell phone providers who bill for service at the end of the month, uh, often under a contract, and prepaid cell phone service providers who bill in advance without a contract? So I'm assuming that's going to be clear when we look at the data. So I guess it's a traditional versus prepaid. So that kind of makes sense. Now, you can see that I've already answered A because that's when my technical interruption actually happened. But you can see that assuming that the population variances from both are equal, is there evidence of a difference? Now, it doesn't say is there evidence that traditional is higher than prepaid or prepaid is higher than traditional. It's different, so I'm going to be focused on the alternative hypothesis it's not equal to. And there's really only one, selection A, so it made it easy. Now, the next thing I want to do is calculate the test statistics. So I want to open this in StatCrunch. Let's just get rid of this because we don't need it. And what I need to do here to make life simple is I need to get this data to where I have one column of traditional and one column of prepaid. So I am going to, if I can remember how to do this, I'm going to go to Arrange and go to Split. So I want to split my ratings by the type of provider. I could open a new data table. I'm not going to do that. I'm just going to work with one data table. So now I have all the prepaid in one and the traditional in the other. So what I want to do now is I want to come to tstat to sample with data. And let's read the problem here. It says let population 1 be the ratings of the traditional, and population 2 be obviously the other, the prepaid. So my hypotheses are set up correctly. I want to pull the variances because again it says assuming the population variances are equal. So that means I need to select that box or I'll get the wrong answer. And I want to show the critical value for an alpha. We can see right here a 0.01. All right, gang, let's compute. So the test statistic is going to be this box right here. So negative point zero, well, negative 0.0, negative 0.10. What are the critical values? Well, that's going to be given to us right here. So we need to go to two places. So I'm going to have negative 2.83 and comma 2.83. Choose the correct conclusion. Well, our test statistic is negative 0.10, which is contained in our critical value range. So we're not going to reject. So by not rejecting, failing to reject, we're concluding that there's no difference in the satisfaction. So there is insufficient evidence of a difference in mean ratings. So A is really the only one that makes sense, right? All right, find the p-value. Well, the p-value is directly from just type it in correctly, so 0.925. And the p-value, again, remember, is the probability of getting our test statistic or one more extreme if the null hypothesis is true. What other assumption is necessary in A? Well, we have kind of a small sample, don't we? Um, we have 13 prepaid. We have 10 traditional. So another assumption, since both are less than 30, it must be assumed, well, that's not true. Since both are less than 30, that's not true. Since both are less than 30, the sampled populations are approximately normal. Both sampled populations are approximately normal. It must be assumed. So I don't like that wording because I don't think it should be assumed that uh, the populations from which the samples were collected is approximately normal. So I don't really like that the way that's put. Now we get into a confidence interval here. So what we can do is just should be able to go back to the two sample test. Yeah. So let's just go up to our options and go edit and click confidence interval instead. And we want a 99% confidence interval instead and hit compute. So the left bound will be negative 8.50 and the right bound is 7.93. Which of the following is the best interpretation? Well, the best interpretation is there's a 0.99% probability that the mean difference is contained in this interval. And the only one I see that represents that is B. Wow, more. So what conclusions can we reach? Since the hypothesis test does not reject the null hypothesis and the confidence interval contains 0, we conclude that there is no difference in the mean satisfaction. All right, well, the next question is actually going to be in the next video, so we are done. Take care.